Significant contribution video. Galileo Galilei. Galileo Galilei was an Italian astronomer who became famous for his works in space and physics. He developed many laws and theories that helped create the base for astronomy. These accomplishments include improving the telescope shortly after it was invented, being one of the co-founders of the scientific method, discovering many objects in space with his improved telescope like Jupiter's moons, and developing many laws of motion and freefall. These are all very important discoveries, but I believe that the laws of motion and freefall are the most vital to science. Galileo Galilei's father sent him to college at the age of 16 to study medicine, but he quickly became interested in mathematics and philosophy and decided to pursue that. He eventually had to drop out of college because of financial issues, which meant that he never got a diploma. Even through all this hardship, Galileo eventually got back into a university as the chair of mathematics, where he continued to do his work. Now, on to what I believe is the most important contribution that Galileo made: the laws of motion and physics. We all know Isaac Newton's law of inertia, right? Every object will remain at rest or in uniform motion in a straight line, unless compelled to change its state by the action of an external force. This means that objects with a greater mass, or heavier, have more inertia, and it takes more force to change its motion. But Galileo Galilei formed the idea and laid out the groundwork for it. One example of this could be a ball rolling down a ramp, where if there's no friction, the ball would roll forward indefinitely at a constant speed. The friction is the external force stopping the ball. Galileo's experiments with rolling balls down inclined planes led to the question of acceleration. Galileo eventually discovered that the acceleration of an object is constant and does not rely on the mass of an object. This means that with no other external force acting upon it, like air resistance, something falling will have the same acceleration no matter how heavy it is. This could also be tied to another thing: terminal velocity. This is when the speed of a falling object becomes constant and it stops accelerating. How is this possible? Well, to answer that question, when gravity is pushing down on an object, it is falling, and because there is air resistance, it would fight back against the gravity. The more an object falls, the more air resistance it gathers. And when the air resistance finally matches the force of gravity, the object stops accelerating and just falls at a constant speed. But here's another problem. What if we had two objects of the same size but different masses? This means that they will encounter the same amount of air resistance. So how can this law work? Well, this can be answered quite simply. The more mass an object has, the harder gravity pulls down on it. And because gravity is pulling harder on the heavier object, it has more inertia, which means it requires more air resistance for it to reach its terminal velocity. Thank you.